All right. So it's 2 o'clock. Make your way back to whichever room you want to end the day in, whether that's the main room where there's plenty of seats available or your breakout room that you're in. All right. So as people are getting settled, I'll read through some of the main takeaways that people posted from their breakout sessions. So one that's actually really interesting and probably to all of you lab folks is that, or analyst folks mainly, that there's an R script in Decipher. So that's pretty cool. Ate too much for lunch. I did as well. Yes. With rural populations, consider the utility of stigmatizing targets, which could have legal ramifications. Yeah. All right. Program coordination differs by state, but overall goals of each state's program are similar. I mean, we all want to know the health of the community, right? That's usually the main goal, right? What can we do to protect communities' health? The importance of data agreements and licensing for maintaining confidentiality. Okay, I'm going. Let's see, what's this last one say? Need for a CDC-led effort for collecting individual states' resources. So like a decision tree. Okay, and it could benefit other programs. Sure. These are all really good takeaways from our breakout sessions. It looks like everyone is having a really good conversation going. I walked into a couple of rooms and I saw lots of good talks happening. So that's great. I'm glad to hear that. So we're gonna go ahead and move on to our final session of the day before our keynote speaker comes on. So get ready for a great session moderated by John Person, who we're very grateful for, was a program committee member as well, helped set up this whole summit, and hopefully you all found it as successful as we have. And John Person is currently the state, territorial, local, and tribal support lead for the CDC's National Wastewater Surveillance System. He has been involved with news since late 2020, where he has helped develop many aspects of the program, including establishing the STLT support team. Previously, John has worked for the Waterborne Disease Prevention Branch and the Louisiana Department of Health as an epidemiologist. John earned his MPH from the Louisiana State University School of Public Health, and these are just a few of the awesome accolades that John has. So thank you very much for moderating. Come on up.
Hello. It's good to see all of you. I feel like I've worked with many friends that I've never seen in person. It's a very strange relationship, but very gratifying to be here today and see all of you and get surprisingly so many hugs. So it's always a bonus. If you don't know me, I like hugs. So well, ask for consent first. I think that's probably the right way to do it. But I'm very honored to be able to introduce the speakers for this topic today. It's a topic that I'm very interested in. Having been with news for our wastewater surveillance for quite a while, in the short scheme of things, of a new field, we've had the chance to work with all of you and work together and to build many great things. We've tried to predict what's coming down the pipe. We've gone with the flow. You can see where this is going, right? I've given you good news and I've given you bad news, and we've had our watershed moments at the time. So many good times, and now the past we've worked on so many things, and kind of one of the hot topics that I'm always trying to push is what's coming in the future. How do we protect wastewater surveillance in a sustainable way? How do we protect the people that we aim to serve? And I'm just really excited to announce this topic. And people come up to ask me. I don't know all the answers, but they say, someone asked me yesterday, John, what do you see in your crystal ball? And I said, well, first off, I don't know all the answers, but I see a lot of waste, and a lot of crap. And any other field, that would be bad news. But for us, that's great. That's what we deal in, is waste and crap. Um, uh, so let me go ahead and introduce you to our topic, which is equity and sustainability and program considerations over the long term. We have some great speakers for you today. And first, I would like to start by introducing Rochelle Holm. She's an associate professor at the Christina Lee Brown Environment Institute at the University of Louisville. She received her doctoral degree in environmental science from Washington State University and has lived in Malawi for the past decade. Uh, she has broad interests in sanitation systems, water quality, public health, and public health, and believes in bridging gaps across the boundaries of research and innovation, practiced by collaborating with communities, government officials, academics, and in the private sector. Her current research includes wastewater surveillance, supporting healthier communities across both Kentucky and Malawi. So please join me in welcoming Dr. Rochelle Holm.
Thank you for the great introduction. So I hope to share with you today a little bit about public perception. What does the public think about all of our WBE work? So our team at the University of Louisville has led 3 papers on the public perception of wastewater surveillance across the United States. Currently, no existing precedent regarding health privacy in the context of wastewater surveillance is available. Participation is not necessarily involuntary. Individuals within a community do not have the option to opt out of our surveillance to preserve their privacy. Authorization comes from public health officials and local governments with broad authority to act and regulate to protect public health and welfare. And no established precedent for community health surveillance of this nature exists, which typically does not involve the regular gathering of public opinion or the provision of notice to gather input regarding sampling acceptance. In contrast, customers can opt out to other public health surveillance, for example, at restaurants or public swimming pools, via a choice to utilize those establishments or not. In addition, public health surveillance results at businesses are often prominently displayed in the form of grades or notices of violations. Alternatively, our wastewater results are most often put on public online dashboards, which are difficult for the public to interpret. So why does public opinion matter? The American public holds opinions on a wide variety of public health topics, ranging from smoking and vaccination to policy issues such as healthcare reforms. The social license around this topic can be affected by spillover effects from politicalization and association with public health interventions, such as lockdowns, as well as trust in policies and responses by federal, state, and local public health agencies. For wastewater surveillance, the intersection of scientific ethics and the public's privacy rights are both important and complex because of the absence of national and international regulation. So the aim of our team was to investigate what is the WBE public knowledge, perception of what is to be monitored, and where surveillance should occur, what are privacy concerns related to sewer surveillance as a public health surveillance tool, and what are the general privacy boundaries of our respondents. We often think of 3 epidemiological frameworks. Many of us have thought a lot about where to sample, both for sample logistics as well as health equity. For example, in Louisville, Kentucky, early in the pandemic, we were over-selecting geographic areas for wastewater testing where clinical testing was not guaranteed. But this requires attention to ethics to make our sample sites not too small, and importantly, no personally identifiable information included. But often when we think about sample size, we think about sewered or pipe sanitation systems. Typically, non-sewered sanitation systems, such as pit latrines in low and middle income countries or septic tanks in many parts of rural America, have smaller population sizes. For the work I will discuss today, public perceptions apply to the urban United States population on pipe sewer networks. Public attention to news peaks in relation to newly reported health threats and wanes when the media coverage fades. The public was seeing wastewater surveillance in the media between 2021 and 2023 regularly, using search terms such as sewage, wastewater, COVID, monitoring, and surveillance. So we have conducted 3 public opinion surveys. The first survey was localized to Louisville, Kentucky. We just wanted to see what were the primary concerns that the public may have or not. So we conducted a survey in August of 2021 as part of an ongoing WBE and COVID-19 community prevalence study. We sent approximately 35,000 randomly selected household invitations within the county. We had 980 adults that were involved in the probability sample, and an additional 1,700 responded to our convenience sample. And then we weighted the samples. The public awareness of tracking SARS-CoV-2 in sewers was low, despite that Louisville had had 9 news articles at that point in Jefferson County. But responses showed that respondents overwhelmingly supported WBE monitoring when greater than 50,000 households were in a sample catchment size, typically representing a treatment plant. Those respondents with a history of COVID-19, though, supported smaller sewer shed sizes. So personal experience of COVID-19 did impact WBE public opinion. We also saw opinions by location vary in the study area across Louisville, this is Jefferson County, suggesting that there is no one generic public opinion on WBE in the city. For example, in Area 1, which encompasses Western Louisville, it had the highest percentage of respondents that wanted those large sample sizes of greater than 50,000 households. Area 4 had a wider range of responses, indicating more variance in that area of the county where WBE was supported for catchment size. In our second and third study, we used Qualtrics, a national research panel provider, to recruit participants to answer an online survey. We had over 3,000 respondents in 2022 answer questions about their knowledge, perceptions of what is to be monitored, where WBE surveillance should occur, and privacy concerns related to sewer surveillance as a public health tool. We also had a privacy attitude questionnaire to assess the general privacy boundaries of respondents. Public health agencies routinely monitor various activities that may pose health threats, including testing for air and water pollution, restaurant inspections for food safety, and inspecting hotels, motels, and public pools. We found that the public was not very aware of sewer surveillance, you probably know that, and even less so than restaurant and pool inspections. We also presented 10 general categories of applications of WBE surveillance: alcohol, disease, gun residue, healthy eating, illicit drugs, lifestyle behaviors, mental illness, prescription medicals, terrorist threats, and toxins to participants, and asked if they would support any of them. Participants were more likely to support wastewater surveillance for disease, environmental toxins, and terrorist threats. In 2022, the most common category respondents wanted to prohibit sampling was at a personal residence. Our concerns in privacy were in sewer shed size that is acceptable and for what targets. We thought that opposing WBE public opinion was related to invasion of privacy, and we thought that privacy may be an important functional use of our nationwide public opinion to gather more widely. For example, legislation opposing COVID-19 sewer monitoring includes North Dakota's House Bill 1348, which was aimed at prohibiting the testing of wastewater for genetic material or evidence of disease, and to provide a penalty. It did not pass, though, in February of 2021. Media reports focused on the privacy concerns of building level surveillance. For those that did not read the National Academy of Sciences report, there's an entire section devoted to WBE privacy concerns and states that CDC should address privacy concerns. We used a validated privacy tool to test privacy concerns. The PAQ assesses the willingness to disclose information that one might want to keep private. Lower scores indicate less willingness to disclose or a higher desire to remain private. The PAQ allowed us to triangulate our other survey questions, and we found that generally, violating liberties was not a dominant feature of WBE. Overall, we did not find nationwide public sentiment that WBE was an invasion into privacy. Our third study was repeated in the winter of 2023, again across the United States using Qualtrics and the same survey tool as 2022. Considering the decrease in the severity and mortality rate of COVID-19 and the increasing polarization of the field of public health from 2022 to 2023, Changes in public opinion were expected regarding wastewater surveillance, but consistently, our survey results again showed public approval for wastewater surveillance for detecting pathogens, toxins, terrorist threats, and illegal activities. Support for surveillance of environmental toxins. That would include industrial chemicals, deadly disease such as Ebola or tuberculosis, terrorist threats such as anthrax, gun residue such as bullet casings and gunpowder were still high in 2023. But individual behavior such as healthy eating and for surveillance of lifestyle behaviors such as smoking and birth control continued to have the lowest support of these applications. Both the 2022 and 2023 results across the United States suggest conducting wastewater surveillance with catchment areas of sufficient size to guarantee individual privacy. Wastewater treatment centers offer the largest possible geographic catchments, usually serving thousands of individuals, making it improbable that individuals could be identified through a pooled sample. In highly urbanized areas, smaller geographic catchment areas representing neighborhoods, for example, may be appropriate because of dense multi-unit housing, while areas dominated by single-family housing on large lots may require larger catchment areas. Some key insights and recommendations from our public opinion research to inform policies and practices in the post-pandemic period. Public education is needed. Currently, there is no anti-wastewater surveillance movement on targets or geographic scale. However, it is important to take action to increase public awareness and buy-in. Potential activities include geo-targeted public education campaigns in areas where knowledge and awareness of WBE are low, as well as inclusion in school environmental education and health curricula. There is also need for public education and advocacy with our utility partners. Wastewater surveillance is supported at levels comparable with other public health surveillance activities. As with pool and restaurant inspections, health departments should establish standard policies and funding for wastewater surveillance. Support extends beyond global public health threats and infectious disease. We should make room for other things to monitor for WBE. Terrorists and toxin offer opportunities to expand WBE with high levels of public support. This may open wastewater as an accepted method for other health risks. But support is conditional. Surveillance targets such as pathogens, toxins, biological and chemical terrorist threats, and illegal activities are generally accepted. Sampling for lifestyle behaviors such as alcohol consumption and eating patterns is generally not accepted. There is overall concern about keeping sample size large to maintain anonymous data. Sampling is most supported when the catchment size ensures fully anonymous households. We infer that the public does not want wastewater surveillance for individual human genetic testing. And lastly, what is the whole opportunity outside of infectious disease? Opening discussion for a broader range of targets to ask the public about their opinion in future surveys is needed. Wastewater surveillance has not received the public pushback that other COVID-19 related health system actors have witnessed. Instead, the public supports the expansion of WBE as a standard to complement public health tools in other areas of health protection. Some next steps are case studies of using wastewater surveillance data for public health interventions and the public opinion on those wastewater guided interventions, including rural communities in the United States, which may have varying opinion given the differing public health dynamics compared with more urban areas. Outside the United States, public opinion may differ regarding this subject, and such studies would be valuable. Working with the University of Kentucky, Central Appalachia, attitudes towards WBE have been surveyed and data analysis is currently in progress. And we find moderate to high support for public health actions in response to WBE in these rural areas also. So look for this work coming up soon. And lastly, I want to acknowledge the amazing team behind the public opinion research and all of our WBE work. Thank you.
Okay, thank you, Dr. Holm, for your expertise in understanding public opinion. That was very informative. Thank you. Next, I would like to introduce someone who I hold in very high regard, one of the kindest and most professional and intelligent people I get to work with, Rachel West. Dr. Rachel West is a molecular microbiologist in the Rapid Response Research and Surveillance Branch in the Wastewater Science Liaison for the National Wastewater Surveillance System at the Centers for Disease Control and prevention. We have acronyms for these, I'll trust. She has a BS in microbiology from the University of Maryland, College Park, and a PhD in molecular microbiology and immunology from Johns Hopkins Bloomberg School of Public Health. Dr. West is interested in translating molecular microbiology methods into effective wastewater surveillance for all communities, as well as integrating community ethics and equity priorities into the growing public health surveillance system. So please join me in welcoming Dr. Rachel West.
Hi, everyone. Right. Well, thank you so much for having me today. And I'm really excited to talk to you about, honestly, it's more of a summary presentation at this point from all of the stories and examples that you've shared throughout the past couple of days. So I'll be speaking about partner engagement and sustaining the national wastewater surveillance system and really relying on these partner networks to keep growing and maintaining our systems. So many of you have probably seen this graphic before, and we often present it as how our data work. So of course, all the samples come from communities, and typically we sample these at wastewater treatment plants. But today, I'm not going to be talking so much about data, more about the partners at each of these levels. So at our communities, we have partnerships with the public. We also have it with community leaders, as some of you have shared over the past couple of days. We have it with, in some cases, policymakers within these communities. Then at our wastewater treatment plants, if we're sampling at the plant, we have plant operators, but we also have lift stations involved, manhole covers. That might be grad students, it might be health department workers, it could be utility operators. And then we have partners, of course, within our laboratories, STLT laboratories, our private labs, commercial labs, and of course, our academic lab partners. Then we get to our STLT health departments. And I have pulled out here one of the particular groups I'm going to focus on today, which is our tribal partners. But of course, our health departments staff within these, both in the wastewater programs, but outside of wastewater programs. Our centers of excellence, of course, are key partners and our academic partners. But much like any award speech, if I started to try to name every partner, they would start playing music and I would have to stop talking today. So what I'd like to focus on today is some key partnership opportunities that we found really important in sustaining wastewater surveillance systems. And I want to emphasize that there are incredible numbers of essential partners, but these are the ones that I'd like to focus on, including utility outreach and retention, which we heard about earlier today, public health lab capacity, building that and making sure that that's sustainable, and then engaging with tribes and tribe serving organizations. So for utility outreach and retention, many of you already know this, and so I'm sort of preaching to the choir, but utilities are of course central to wastewater surveillance and their continued participation is critical, but it's often voluntary. This continued work throughout the pandemic and now continued to additional pathogens can be once weekly. Some folks do it 5 times a week, and this time is all towards their communities and their public health. So bringing utilities to the table early and consistently is, we have found, to be really important in building up that partnership. So building up those utility networks, not only bringing them to the table, but truly listening to them and making it collaborative. So when engaging early, talk to them about their capacity, both time and the number of staff that they have, if they're expecting any turnover soon. Engaging with them to learn about their concerns, their knowledge of wastewater surveillance and what they think of it. Once you've started engaging them, engage with them often. Have two-way conversations where you're sharing data, where you're asking them their thoughts. There have been many times where I am so grateful because I've reached out to utilities asking about, have you had any major weather events lately? And they're always incredibly responsive and informative. And that can also inform your data and your metrics and how you design your sampling plans. And then incorporating feedback, incorporating their expertise, and acknowledging the work that they're doing so that you can strengthen the wastewater surveillance system even more, using their expertise and their perspectives on what's working and what isn't. And then once you've done that outreach, how do we support and retain them? Again, this was spoken on eloquently earlier, but there are a few ways that we want to focus on for utility support and retention. And one of those is logistics. So improving sampling strategies. That goes back to talking to the utilities and understanding their capacity, but also connecting them with the lab teams and the health departments continuously. Investing time early to understand their logistics needs. And yes, that's certainly referring to shipping. Brenna spoke on this yesterday very well, that there need to be flexibilities in shipping and understanding how to get their samples to the lab and listening to them if a courier is not working out. One of the things that is newer that is through ELC is you can use those funds to support courier costs. And sometimes that can encourage utility retention. Further, for equipment, supporting them and updating equipment, which our partners at WEF are so excellent at doing, the auto sampler program, and also maintaining PPE supplies. We know how much they're facing, but particularly when we talk about additional pathogens we're testing for, how do we communicate with them about PPE so that they and their loved ones feel comfortable at work? And then also trying to find ways to make sampling easier. What days work for them? How can you align with their existing procedures so that you're not adding a burden? As for staffing, trying to support staff professional development. I know that many of you have started to work with programs on credit hours so that this can count towards their professional development. And then connecting utility partners with public health lab partners so that they can share their expertise and also understand all the elements of the wastewater surveillance system. And actually, several of you have mentioned trust. That's a really important resource that we often talk about funding and we talk about time, but trust is an incredibly important resource for retaining utilities and really maintaining true networks that we can rely upon. So now I want to focus a little bit more on public health lab capacity building. So we know that our public health labs are on the cutting edge of wastewater surveillance, and our timely, high quality data depends on them. And the public health lab capacity to which I'm referring is including the logistics and the science, but also the workforce within the lab. We have scientific innovation, but we also have opportunities to innovate training programs, whether that's just within a health department, but it can also be with academic partners and thinking about how you can incorporate this into higher education. And we also know that innovation of methods and troubleshooting is incredibly important with our public health lab partners. They have close connections to utilities and to health departments. And so how can we better support that? So there are several different ways, but some of the ways I'd like to focus on today is really strengthening labs through effective resources. For biosafety, sharing clear standards when we can, and if we can't share them, advocating for that so that we can communicate the needs to our partners, they can communicate those to their other partners so that things can be implemented in a reasonable timeline and in a way that's safe for all lab workers. Also fostering discussions on needs and challenges around biosafety, particularly when thinking about new targets, understanding what different communities are facing when considering biosafety levels, and bringing other agencies and partnerships into the room when it is relevant. We also want to focus on training. So connecting lab members to trainings, as I said, with utility operators and members of that community, trying to professionally develop these folks and connect them with others within the wastewater surveillance network, encouraging attendance at trainings and conferences such as this one, and also working to develop trainings for when there is staff turnover, also to encourage graduate students and undergraduate students who might be interested, and trying to strengthen the network, not only by retaining folks, but attracting folks and working to cultivate their knowledge over time. The other group that I'd like to speak about today is working with tribal communities. So all of us know that American Indian and Alaska Native populations face disproportionate health impacts. We know this with COVID-19. It is oftentimes with other diseases. And we also know that in the COVID-19 pandemic, tribes and tribe-serving organizations implemented wastewater surveillance for these pathogen targets and beyond. And this is a graphical abstract from a paper from Dr. Conroy Ben that recently came out. It was really looking at how connected tribal communities were to sewer systems. Someone spoke earlier about the fact that 1 in 5 Americans is not connected to a sewer system, but understanding how we can support tribes at one of the most basic levels. Are they connected to a sewer system? That's something that academic and tribe serving organizations have already been doing. So why I'm saying this is because it's important for us to acknowledge the expertise that's already there in wastewater surveillance, environmental health, and public health within tribal communities, and using that expertise to strengthen our existing wastewater surveillance system. And when I say that infrastructure, I'm referring to the infrastructure that's tailored for tribal communities, but also our overall infrastructure. How can we incorporate their expertise in that way? And this can be through direct outreach to tribes. It can also be through working with area Indian health boards, and it can be working with tribal epicenters. So when we're working to find solutions to collaborate with tribal communities and building a wastewater surveillance system, this can really only be done in an equitable way that best serves them by bringing them to the table very early on from the beginning. I know that many marginalized communities often say nothing about us without us, and this very much applies to wastewater surveillance. Um, and how you bring them to the table can particularly matter working with their trusted partners and understanding who should be in the room. Is it public health? Is it environmental health? Is it an advocacy group that they typically work with? Who should not be in the room? That's also very important to consider. And that takes outreach and really listening to these communities. And I also want to say that we're still learning this and best practices from all of you, but also from our tribal partners. And this can be an iterative learning process. So working to learn their priorities in building up these surveillance systems can be looking at their infrastructure. What does their sewer system look like? Is it connected to a community center or a casino? Also understanding their needs for data. What are their needs currently for timely data and for which pathogens? Their communication styles. What do they want to focus on? How do they like to speak about public health in their community? What mechanisms you should be using? Is it a radio program? Is it through the elders? Trying to think about that and incorporating that from the very beginning can help build that trust. And then, of course, translating this to public health action. What are their priorities for their community health? And how can we use wastewater surveillance to serve that? So all of these rely on relationship building and respect for tribal sovereignty, understanding that outreach is should be early, but also has to be continuous, even if it can be a different pace than you might be used to. Respecting their processes and their hierarchical structures if they have them. This also ties sovereignty to data protection. So data sovereignty is particularly important when working with tribal communities and understanding what their data needs are, who they want it shared with and who they don't want it shared with. That's something that really helps to establish trust early on and is really important in understanding, particularly with wastewater surveillance. And then, of course, having these ongoing conversations with communities. How is wastewater surveillance working for them? Are there gaps that they're seeing? Are there obstacles that they're facing that we can help support? So some of the things that we've learned over the past few years about working with tribes is to learn the status and history of wastewater surveillance with the tribe. Have they participated in this previously? And if so, how did it go? Did they find it useful, but they had staff retention issues, or did it not go well? And how can you try to support them where they are and their perception of wastewater surveillance? Also learning and understanding the history of each tribe with public health and governments in general, and understanding how that will inform your approach. Learning about and engaging their trusted partners, as I mentioned earlier, understanding and respecting who you should have in the room who can make these decisions for the community, and that it may need to go beyond these rooms, and that you want to provide resources to the tribe and the tribe serving organizations so that they can adequately inform all of their trusted partners. Deferring to their timelines and processes, trying to be respectful and understanding of their needs and who they need to explain all of these different elements to. Trying to engage, particularly in person, is very valuable with their leadership and explaining what wastewater surveillance is and what it can do for their community. I know that particularly one of our centers of excellence. I hope it's okay to give them a shout out here. They worked with a tribal community to understand how to better frame wastewater surveillance and the language around it so that it could strengthen that relationship and strengthen their surveillance system as a whole. Again, ensuring data protection and sovereignty, understanding what protections can be put in place and what can't be put in place, and being very transparent about that. And also listening to them about their needs. If they have further questions or they have an idea for a data protection that has worked well for them in the past, asking about that and learning, using that to strengthen your surveillance system. Supporting their outreach to their community. We have some partners who have been working on educational resources for their community, radio programs that have been really successful, and how you can best support that from your side while also incorporating their expertise. So really blending those resources. And then, of course, incorporating their health knowledge and priorities for surveillance. Communicating with them about what maybe your jurisdiction priorities are, but also listening to what current surveillance gaps they might have or priorities that their community has for their health, what pathogens those might be, what other targets those might be, and how that might be incorporated in their system. So with that, I want to thank you and just thank you all for sharing all of your stories of examples of building these partnerships over the past 2 days. If you take one thing away from this, I hope that you take that building these partnerships allows us to be flexible and nimble and give our communities the best science we can. So thank you.
Okay, thank you, Dr. West. Okay, next I would like to introduce someone who was my previous mentor who encouraged me into wastewater surveillance, which I'm thankful for all the time. I would like to introduce Jonathon Yoder. He's the Deputy Division Director for the Division of Infectious Disease Readiness and Innovation, also known as DIDRI. Resides within the National Center for Emerging and Zoonotic Infectious Diseases. DIDRI works to build and strengthen public health capacity by enhancing the ability of CDC and its public health partners to prepare for and prevent and respond to infectious diseases, including outbreaks, bioterrorism, and other public health emergencies. So join me in welcoming Jonathon Yoder.
All right, I'm really excited to talk to you about this topic. Although I will say at the beginning that at the end of it, you might have more questions about pandemic preparedness than you do right now. I certainly do. But before we, and again, this gets back to this quote by Niels Bohr, which is prediction is very difficult, particularly if it's about the future. So we're really, when we talk about pandemics, when we talk about public health response, we're really thinking ahead to what's coming. And we don't have that answer. If we did, our life would be so much easier. I do, if you didn't notice over in the food court across the street, they do have this unintentional wastewater sign for it that we prepared for you. So I think that's a good omen for where we're going. Don't worry that it just says waste and water. It really says wastewater. Before we get started, show of hands, before January of 2020, how many of you were working in wastewater surveillance? Great. I salute you. You're the pioneers. But I think it just goes to show how new of a field this is for most of us. And so I'll apologize to those of you who raised your hands. But when I think about in January of 2020, and we talked about wastewater surveillance, here are the things we were either doing or thinking about. Drugs, opioids, antibiotic resistance, polio, maybe the enteric viruses. So I apologize if I missed some on there, but certainly not on our radar were coronaviruses for wastewater surveillance. And then if you jump forward 2 years, what were our priorities in January of 2022? It was SARS-CoV-2. Mpox was not on our radar as something that we were planning to roll out large-scale wastewater surveillance for. And it just shows that came up quickly, and we had to pivot. And then if you go forward 2 more years to January of this year, here's, again, this is not the full list. Some of you are doing many more than this. You have many more priorities than this, but these were probably on your list somewhere. SARS-CoV-2, Mpox, clade 2, not clade 1, clade 2, influenza A and B, and RSV. Again, we were thinking about clade 1, but we weren't necessarily doing surveillance for it. But what wasn't on our radar was highly pathogenic avian influenza in dairy cows. Like that was not something that we thought, hey, let's set up our wastewater surveillance to look for that. And so I think the point of all of this backwards thinking is just that when we talk about any kind of framework for prioritizing, and we want to make sure that it's fit for pandemics and public health response, we really have to be nimble. And you all have been so nimble, so responsive. And I think that's the hallmark of why we've gotten so much done. But it's not necessarily easy. And I want to present is a little bit of a framework that we're thinking about to do that. And I guess, again, not going to go through this figure, but it really is why is wastewater surveillance important for pandemics? Because it flips that what we think of as our surveillance pyramid on its head, right? We're not just thinking of only the people who die or only the people who get severely ill that we get to find information for. We're getting information on the community. We're getting information on that whole sample, whether they present for medical care, whether they become severely ill, whether they are fortunate enough to get tested and the test gets reported to public health. We can capture that information. And we've always thought about wastewater surveillance as sort of, these are 4 buckets. They're not distinct buckets. There's probably more buckets than this. And I won't keep the bucket thing going, but I think we talk about emergency response. We talk about pandemic preparedness in there. We talk about emerging infection, and we talk about BT. And each of these have a bit of a different focus, framework, type of system that's needed. But I think focusing just particularly on the pandemic preparedness, it is one of those things that wastewater surveillance should always be ready to pivot towards, even while we have our core surveillance, our core pathogen targets. And I think when we talk about new pathogens, this is not groundbreaking, but these are some of the things we think about, that you all think about. I've heard you talk about the last couple of days. That as we think about new pathogens, new targets, can you detect it in wastewater? Does it complement the public health data that you're already getting by filling a gap? And if you detect it or you quantify it, will it inform public health action? We had a really robust discussion of what is public health action, in our previous breakout, because it's different than clinical action that you would take based on a patient in front of you. But it's really important. And does it have support from the community? And what I'll present in just a minute is a bit of a draft of us thinking about that framework and trying to put it in a decision tree. But what we want to do at a national level is think of a regular timeline for reviewing and getting input on what our targets could be. How do we get input? How do we make recommendations? How do we finalize decisions for the national system, which frankly might be different than the things you prioritize locally? There's certainly some things that you may be really important locally that don't make sense to do nationally. And then how do we update that regularly, get input? And then is this useful? Again, this is a question that I don't know if I had the answer for, but if this framework, well, is it just for those normal pathogens, or could it also be used for those pathogens of pandemic potential? I think it can, but I want to walk through this, the next few slides, just give you an idea of what this looks like. Again, it's still a draft. We're not quite at the point where it's finalized, but if we think of it, if you go all the way to the bottom left, if we were to start plotting pathogens on this grid, at the bottom left, you have those things that are poor candidates for wastewater surveillance, or they're just not ready for wastewater surveillance. There's reasons why they could need more research. They're on the bottom right, or on the top left, it could be a low priority for public health, meaning there's several reasons why they're not quite there. And at the upper right, there's ones that they rise to that level of being ready for implementation. And this is a super busy slide, but the way we've mostly broken this down, if you look in the left yellow hand questions, they're really around those are around the relevance. Is it relevant to do wastewater surveillance? And then the purple and the blue sides are really about implementation. Can we implement it nationally? And can you implement it at the front lines? And again, I'll unpack this a little bit further, but again, and so both of those domains, relevance and feasibility are important. And I didn't put the actual number scores up here because I don't think it's important for this talk, but there are number scores. You'd get a score once you went through that process, and think about where it fits on that quadrant. And again, this is just broken down the same questions into low, medium, high for each of those. Is it target? Is it shed or detectable? Down in the purple section, is there community support for it? And some things, there could be a lot of community support. We heard this from Rochelle, that there's a lot of support, and then some that there's not as much support. And then down at the bottom section is it feasible to adapt clinical assays, or do we actually have the resources to put this into practice? And the reason I go through that is that when we look at things of pandemic potential, again, this is just the WHO list. This is published. I think it's under revision. They're reviewing this. But if you just looked at this one and you started trying to plot that on that, run that through this grid. I'm not going to put these actually on there because we've only just done it in draft form. But what you find is things like some of the viral hemorrhagic fevers start to cluster down at the bottom left. Not because we can't detect them. We can detect them, but they would be really challenging to do with the biosafety, biosecurity in a wastewater lab. And we do have other surveillance that probably does a good job of picking them up, so that the value doesn't really rise to the top. But again, as we work through this, if there's interest in this from your side, glad to talk through this more. But I do think this type of framework is what we're all going to need to think through as we develop sustainable systems that are also nimble enough to adjust to what's coming. Again, interesting from the last few weeks, this paper just published from the Paris Olympics, where they went through a similar process. They considered 60 different targets. These are, interestingly, they came out at a lot of the same place that we have so far, where these are the criteria. I'm not going to read this, but if you're interested in looking this up, that reference is available in Eurosurveillance that you could look through. But I think they had a really interesting approach to this, and something that I think could be adapted. And I'll just give very briefly the example of influenza A and H5, because I think this is kind of a real world thing where, initially influenza A, influenza B has been on our list. And when H5 came up this year, we wanted to look at influenza A. And I think that's important. We have an initial dashboard up. It's going to be revised. We're working on our metrics, but we also, our partners at Wastewater Scan, and many of the rest of you have also looked at H5. And initially, what's the extra value of this? I think we're finding out what that is. It's not that we have all the answers. It's not that you have all the answers. But I think going through this process, getting more specific, learning more, collecting the data has taught us a lot. And I think I'm not going to go into this because Rachel did a great job talking about the partnership, because it's all of you that make this work. And I'm really excited for this meeting, for all of the work that's gone into this. And so in summary, this relies on a strong network. This relies on us taking what you're learning, what the academics are learning, pulling it into what we're doing. It's about building trust, because anytime we do pandemic response, that's a big piece of that. And I think we've learned more and more about that recently. And it's about maintaining that flexibility. Meaning, if we're only able to do if all of our capacity is in our standard pathogens, then we're not able to maintain that flexibility to respond. And so here's the questions I have. How do we balance that, our ongoing wastewater surveillance, with that flexibility? And how do we prioritize readiness for infectious disease threats? Prioritize assay development, prioritize those public health response tools, prioritize what we need to do for data visualization so that we maintain the right level of public awareness of what we're doing and how we can respond. I'm really excited about working together with all of you, because I think there's no one of us that has these answers, but in order to be ready for what's coming, this is what we're going to have to do together. So thank you.
All right. Lastly, I'd like to introduce one of our esteemed partners and one of the leaders of one of our centers of excellence, Dr. Alex Yu. Dr. Yu is an infectious disease physician and currently serves as chief of the surveillance section in the Division of Communicable Disease Control at the California Department of Public Health. As part of California's COVID-19 pandemic response, Dr. Yu co-led the establishment of CDPH's wastewater surveillance program, now a center of excellence at the CDC, as part of the National Wastewater Surveillance System. CDPH's wastewater program is a collaborative effort involving multiple state agencies, the CDC, wastewater utilities, local health departments, and academic researchers. So thank you, and please help me in welcoming Dr. Alex Yu.
All right. So I have the pleasure of closing out the session, and I'm going to talk about data standardization, but I'm not going to get too in the weeds, so you guys can rest easy, and hopefully this will be interesting. Okay, here we go. So I'm going to talk a little bit about some of the issues that we've seen around non-standardized data and how that is relevant to the idea about sustainability, at least for us in California, and some considerations that we've thought about and some potential solutions that we've come across that have helped us in California. And so, sewer shed data is great. We're here at a wastewater conference. We all love it. It's wonderful. And part of the joy and the value of wastewater data is that it's able to give us really granular data, right? Like, so I live in San Francisco, and I live in the western half of the city, right? And you can kind of see here circled that part of the city is yellow, right? And on this map, that means that code levels there right now are medium, whereas the rest of the Bay Area and everywhere else, including eastern San Francisco, is red. And so COVID levels there are high, right? And maybe that provides value to me, right? Like in the Oceanside wastewater plant there, which is the sewer shed that I live in, trends seem to be going down, whereas perhaps in the rest of the Bay, it's still going up. And so this maybe is useful to me for my own risk assessment. It can be useful to me maybe if I was at the county level or at the state public health level to give us information about kind of regional or very specific trends, right? And so this is part of why we love wastewater data. But if you ask me what's going on in the Bay Area, right? Like if you were to take a look at this map, you have all these different colors showing different levels. You have all these different wastewater sheds, which is wonderful. But how do we actually say what's going on in the Bay Area or in California in general, right? And this is one of the complexities about wastewater data and how it becomes difficult when you're talking about using it for what we actually want to get out of it, right? For instance, this LA Times article from this summer says COVID in California, right? So as at the state level, it keeps rising. Wastewater levels are worse than last summer. So comparing now to some other time point that maybe I have some mental reference for. But this is not really how wastewater data is set up, right? And the questions that people care about really are what's going on with the disease, right? On the basic level. Is it what's happening at the county level, the regional, state, or the national level? Is it higher in my place versus your place? Is it higher compared to last summer or some other kind of point of reference? All right, so if those are the problems with wastewater data, right, can't we just add it up or sum it or some other thing to kind of get an idea of what's going on? And as it turns out, I'm sure as many of you have come across, the details are complex and it's incompletely understood differences between labs and methods and sites really make it so that it's not just something that we can just add up. Right. And so here are data from one of our sites over time from 2022 to 2024. Right. And this is the same site now with two labs that have been monitoring there at the same time. So our drinking water radiation lab at CDPH and then the wastewater scan program. Right. And one uses liquids, the other one uses solids, other method differences, et cetera. You can see that while the trends maybe are generally all aligned here, that the magnitudes aren't exactly the same. Right. And maybe even the differences aren't consistent over time. So in 2022, you can see that there's a moderate difference between the measurements at these sites. And then in 2024, though, maybe that difference has kind of gone away, right? So how do we interpret this if we're thinking about lab differences? And maybe we say, oh, we just care about trends. Nobody cares about all that 5 to the 10th to the millionth E copies of whatever. And so here's a comparison of the trends at this site on a weekly basis over time. And you can see, so green here is decreasing, yellow is increasing, blue is plateau. And for the most part, there's alignment, but on a week-to-week basis, there are times when there's discordance, right? And if you're at a public health agency or otherwise, and you're trying to make decisions on wastewater, this can be problematic. And there's other issues too, right? So direct comparisons between sites may not actually reflect underlying disease activity, right? We think about things not as pure concentrations. We kind of want to maybe we can rank order things, and that helps us compare. Is it higher in my place than yours? So on the left here is a population flow normalized wastewater concentrations at 6 sites in Southern California, and then on the right side are epi incidence rates from those same sewer sheds. And the colors are the same. And so if you look at, let's say, the green line, that's the highest wastewater concentration over time in this in Southern California. And then correspondingly, from incidence perspective, it's also the highest. So that's great. That's what we want to see, right? And then if we take the orange line here, the orange city, maybe that's the second highest or maybe even the highest in wastewater concentrations. And if we look at the incidence, maybe that starts to fall into the middle of the pack there. Now, if we take a look at the bottom here, so the dark purple line, lowest wastewater concentration for sure. But if we look at the incidence data, now this is actually the second highest incidence in Southern California, right? And this becomes problematic, right? So the fourth here in the middle of the pack wastewater wise, but clearly the lowest from an incidence perspective, right? And the problem is that we look at the left graph, right? We like to be able to compare and think about things, and we are interpreting it as the right graph, right? And there's all sorts of reasons why the right graph may not be perfect either. But at the end of the day, this is the kind of comparisons that we're trying to get out of wastewater data. And just thinking about this for non-COVID and in other pathogens and kind of other things, right? So MPOX, we think about detect, non-detect, right? So this is data from all of our California sites being monitored by our drinking water radiation lab, except for 3 that I've dropped out. And blue are clinical cases that are detected within sewer sheds with wastewater monitoring over time. And then orange are the number of detections in wastewater, right? So you can see there's detections almost every week. They seem to follow the epi trends for the most part, et cetera, et cetera. So this is great. This is what we want to see. But if we look at 3 California sites that I dropped out, these are sites that we've had concerns about inhibition and other things like that. We see that it's not quite that simple, right? And so lots of cases still, but very, very few wastewater detections, right? And if you were to apply the kind of like expected from the left graph, that's not what you're seeing in the right graph. And when we think about aggregating or even comparing or interpreting data from any of these sites, we might be thinking that wastewater is going to work as well there, but because of these inhibitions and other things like that, perhaps we can't quite think about it that simply. So what are we doing in California, right? And why is this relevant for sustainability? So we are a large state. And our wastewater program is made up of a network of multiple labs. Right now, it's about 80 sites. That covers about 38 counties. We have over 40 million people in the state. And our network is made up of 3 main labs with 4 major laboratory methods that are being used. And there's also variation in sample types. So there's 2 main types of samples that are being taken, influent and solids. And there's varied sampling frequency from 1 time a week to 7 times a week. Moving forward, we know that some of these programs are going to decrease their sites. And we expect and we hope that our county programs are going to be able to take on some of the workload that's necessary. And commercial laboratories are going to fill in some of the gap that's needed. And then there probably are going to be more laboratories and more methods that are made to help adjust to what's needed at the local level. And so what does that all mean? I think that means that the ability to receive data from a variety of sources and use it is important for sustainability. And so work with what you have, right? I think this is sort of the key. And I think this isn't necessarily a detriment to the system. I think this is something that we can harness, right? I think we understand the differences and the problems of data comparability, and we can use that to help create sustainable networks that move us into the future, right? But it's important as we think about all these little intricacies, right? Not to necessarily get too hung up on them, but keeping them in mind will help us think about how we can use it. And also we need to think about the end product, right? How is this going to get interpreted, right? When we show that one single figure, that one single simple dashboard that we all want, or say it's high, what does that actually mean to the reader? Right. So here are some of the things that we've thought about to try to get around some of these problems. So picking a single lab, right? So that's helpful, right, for some of these problems, right? But which one? So right now, for a single site, if we have overlapping sampling from different labs, we try to select the lab that has the highest sampling frequency, the longest sampling period, and the most recent sampling dates. So the samples that we have the most recent data from. And then when we talk about aggregating data, then we try to stick to just a single lab too. And then that helps, we think, with comparability, right? Doesn't fix all your problems, right? What if your region only has, let's say, 5 or 10 sites all together and they come from multiple labs? You can't just say pick one of them. You're not going to have any data left, right? So are there ways to get around it? And so here, I think inter-lab comparisons help to understand the similarities and differences. Can we even compare them at all, or not, and what the kind of nuances might be? And if methods are really, really different, or it can be confusing and can be misleading to try to plot them together, right? So this is a single site on the left here. You can see that there's 4 different labs that have been used at this site over time and represented by different colors, right? And if we just put it up together like this, it's going to be really easy to misinterpret, right? I don't really know how to make sense of it. So when things like this happens, and there can be ways to, for instance, transform the data to make them more comparable, right? So here is a method, this is the CDC's WVAL method, and using that method at this site for these data, make this lab information much more comparable all of a sudden, right? This data, I think inherently seems more understandable to us. But even when we do things like this and we like it, it's important for us to label things when they change, right? And to have caution, even if we feel good about it, about comparing between now and, let's say, last summer, right? Like if we're using data from a different lab from last summer, is it really fair, even if we like the transformation method, to say it's higher or lower or something like that? Clear definitions and inclusion criteria can be helpful. So what's a recent trend, right? Like, is a high level relative to what? A lot of these are subjective calls, right? And so making sure we have clear definitions of what they are and why we've chosen them is important. Calls for what kind of data we want to include. So for trend calls, we have to have at least 1 sample in the past 10 days, and at least 3 samples in the past 21 days to keep the site or to report a trend at all. Same with level calls. We have criteria for how we're going to call levels and what's needed. For aggregation, we want to have at least a certain number of sites with enough data to report it, right? And if we don't have recent data, then we'll drop the number. We'll drop the site, even if that hurts our aggregation at the end, or may not be able to call a trend at the aggregated level. All right, so normalization. I'm not going to talk a lot about normalization because I think you could have a whole talk about normalization. But right, the idea here is that you have a measure to correct for all the problems that I've just talked about, right? So ideally, this would fix all these problems. And there's lots of different methods out there, including correcting for PMLOD, population, flow normalization, and some of these may help with comparability, right? But the impact of these different normalization practices, at least from our experience across sites and labs, can vary, right? And I'm not sure that there's a consistent one that helps at all sites. From our data, we've taken a look, and some places we've seen that even using the same lab, for some sites, the method will hurt or help or be the same, right? And so at that point, what do you do, right? So what we've done is, because we have been able to analyze our data set, we can help see if, like, okay, well, this normalization generally improves things. So we're going to go with that. For that lab, it doesn't tend to help, so we're not going to bother with this additional correction method. So I think that can be helpful. At the end of the day, some of these design choices are really important, right? So this map here, you can see most of California is red, except for the region, the northern region, which is mostly rural, and it's marked gray, which means not enough data, right? And this is because we don't have enough sites with recent enough data, so we've dropped it out and said not enough data. Great, but unfortunately, this means that almost every week, our Northern California area is marked gray. And is that really fair, right? Is it helpful to be gray all the time? Or should we be more relaxed in our case definition right here to say, oh, well, we'll take samples from 2 weeks old, right? A lot of the problems sometimes are rural sites have more difficulty shipping, right? So can we relax that? But then at the same time, if we relax standards, how does that impact the rest of the state? And is it fair, let's say, if it's, you only have 2 or 3 sites in all rural north and you're trying to characterize this massive area, is it fair to use just a few sites with a few data points to make that call? And so these are the kinds of decisions, obviously, that you have to weigh when thinking about those decisions. All right, so aggregation of wastewater data, right? So what are the ways that we can and have tried to look at this? So at the end of the day, right, the goal is to go from all these different colors and whatever's going on in an area and come up with a single kind of summary of what's going on, right? So the graph on the right. So this is the Bay Area region, and here we've been able to aggregate, and what we've traditionally been doing is that for each region, we select a single lab source, we apply an exclusion criteria, we'll take rolling averages for each site, and then we'll population weight that average, and then we'll sum average the sites. And then that makes our regional aggregate. And why do we think population weighting is important, right? So this is SARS-CoV-2 levels in Southern California over time. And you can see that there's, of course, differences between sites. You might expect that. But for instance, this site in gray is one of the has higher SARS-CoV-2 concentrations. And that comes from a site in Santa Barbara that represents about 100,000 people, right? And meanwhile, this is in green coming from LA County, which the sewer shed serves about 3.5 million people, right? So 35 times as much population, and obviously important for Southern California compared to Santa Barbara, right? So if without population weighting and you average these out, then Santa Barbara is worth as much in your averaging as LA County, right? And is that fair? I mean, I think it depends, right, on what you're actually trying to say. But at least in our calculus, we think that there is something that's relevant about population here to kind of calling regional averages. So this is why we've thought about population weighting as important. And so here with population weighting, we get things like the gray kind of line here. And this is the equation if you want to see about population weighting. But we know this is not the only method, and there are other ones, right, including CDC's WVAL or wastewater viral activity levels method. And so for this method, the general idea is that you log transform the wastewater concentrations over the past year, you calculate a baseline value, then you can calculate what a standard deviation for that value is, and then you convert your data into those standard deviations, right? You exponentiate that value over time. This becomes your WVAL metric, and then you can calculate averages based on that, and you can take a median, and that represents your regional average. It's not really technically complex, but it is somewhat conceptually harder to think about than, say, population weighting and things like that, but has lots of advantages. So how do these methods compare, right? So we wanted to see how does this look like in California compared to what we've been doing. And so this is work done by Elizabeth Bornor, an EPI on our wastewater team. And she's taken done some preliminary work around this. And so this is statewide wastewater aggregated data using population weighting in red and then WVAL in blue, and then statewide test positivities in dashed black line, right? And you see over time, they generally actually correlate pretty well. They capture the general magnitudes and trends, and that's what we really want to see, right? And formal tests of correlation using Kendall's tau are pretty equivalent, right? And so this is good. And I think this gives us some confidence in both of these methods. When you get down to the regional or at the county level, and that's what I'm showing here, then there's some more differences that start to kind of shake out. And it seems that the WVAL method seems to work better at the county level, right? And so in San Luis Obispo, for instance, the blue, which is WVAL, seems to track better with the test positivity than, say, the population weighting does. Of course, no method is perfect, right? And in this example in El Dorado, you can see that neither really track with test positivity. And maybe this is test positivity that's the problem. But either way, we're still working out what these all mean. From a tau perspective, WVAL seems to perform better than population weighting. So we have some next steps that we want to take to look at WVAL and pop weighting, including evaluating how these methods compare for kind of the most relevant public health measures. It's fine if it works most of the time, but what do we actually care about in public health is when does a surge start? When is it peaking? When is it ending, right? What's the magnitude of those? So how do these methods work for those things? And then try to repeat that validation for other pathogens like flu, and then determine how we can handle sites with multiple lab sampling in this kind of framework of aggregation. And then we want to try to test some alterations to WVAL, see if that enhances performance. For instance, if we were to do population weighting along with WVAL. All right, so in summary, we think, at least for us in California, and I'm sure this might be true in other places, a network approach really can help with sustainability. And interlab and intersite differences are important. I think we should embrace them while recognizing and considering them when we think about data analysis and reporting and dashboards and all those things, but especially when we're thinking about how do we interpret and act on it. And there are methods to help, right? I think for us, it's been choosing a single lab or a method or site that best suits the question we're trying to answer, and that can change for different situations. Interlab comparisons to understand the nuances and differences, using thoughtful inclusion and exclusion criteria and trying to stick with those. And then using aggregation or transformation methods such as WVAL or population weighting. And then recognizing that one size may not fit all, right? So what we're showing here may not work for MPOX, which is a quantitative kind of result, right? And so different situations or different pathogens may require different approaches altogether and need to be thought about that way. All right, just to close, I want to say thank you, especially to our Center of Excellence partners, and that includes Dr. Ali Bam at Stanford, Dr. Marlene Wolf at Emory, and all of their labs and students that have helped us through the years, Greg Kester at the California Association of Sanitation Agencies, Brian Bajaka at the SFPUC, and many, many other partners, including within CDPH, our wastewater team, and Dr. Duke Bujo, who's really been important for us as a leader and for his guidance, our laboratory, all of our programs at CDPH that have helped us, including, for instance, the immunization team and others who've helped, all of our local health departments, State Water Resources Control Board, our other academic partners who've been useful and helpful and critical for our program throughout time, including UC Berkeley, UC Davis, UC Merced, UC San Diego, the many, many, many utilities, of course, within California. I think Rachel's talked about all of these types of partnerships and how important and why they are important, including NALCO and her support and leadership in the utility space, and to us really as a program, and to CDC and the news program, especially John Person, who's really been a critical piece for communication, collaboration, and a link between, the CDC and us, and then the news team in general, and for all the leadership and guidance in this space. WEF, of course, for hosting and also for helping to develop these partnerships, without which none of this would be relevant, wouldn't be possible. And same with APHL, support our laboratories and try to help us with this question about sustainability. So really appreciate all of you and everybody in this space. But thanks.
So if I can have all our presenters join us up front. So if you have questions, please. Yes. Oh, you have a question. Okay, we'll start with an online question.
Okay. Alex, you have a couple of questions actually. So one is, I have seen normalization using mitochondrial gene NADH as an internal control for normalizing COVID. In your opinion, is using a human gene more reliable or representative than using PMMOV? And what are your thoughts?
I don't have any thoughts. I don't know enough about that. I think we've looked at PMMOV and flow and population and thought about some of those types of markers rather than some of the ones that you're mentioning. So I don't know. Can speak to that. Sorry.
Okay, other online questions? I don't see anyone lining up quite yet.
It's also for Alex, but this should be an easier one. You get kudos. Great talk, Alex. Aggregate data makes sense to EPIs, but how accurate is that data at state level for different targets to make any public health decisions? Okay, maybe that's not an easier question.
Yeah, it's a good question. I think it is. It's like any surveillance system at the end of the day. Wastewater is a sentinel surveillance system, and for better or worse, it's the sum of its parts, right? With all the kind of caveats of that. But I think in general, wastewater at the state level, regional level, when we aggregate, I think really does provide important insight, especially now when we have some of our other surveillance metrics are less robust as they used to be. But I think it still performs well and has been relatively stable. And I think even for all the caveats there are, I think that when you aggregate them, they do well and really do reflect what's going on in the community.
I've got more online questions.
Okay.
Okay. No one's lining up. All right.
Everyone's
This one's
too tired to get on their feet.
I know. I don't blame you. For Rochelle, any reason why there's less urban support in Kentucky for drug surveillance? And then I have a follow-up to that.
That's a very good question. So we saw overwhelming response for terrorist threats, diseases, and illicit drug use. That was a nationwide study that we did, and then we also did it just for Louisville. The University of Kentucky is also doing opiate surveillance work. So I think that look for more information on that later in the year as we compare rural and urban areas of Kentucky.
Okay, great. Fair enough. And one, if you are willing to take one more question related to that, any thoughts on why support/opposition is similar for prescription and illicit drugs?
That is a very good question. And I think that leads into, we only had 10 categories that we asked the public about for their support. And so more research is needed in this field to determine what are the boundaries and to dive deeper into that topic.
Okay, any other questions? Okay, let's wrap this up. Thanks, everyone.
All right. Thank you all for the great presentations and John for being an excellent moderator. Like always, we really appreciate that. Up next, we have our closing presentation, Nicole Fehrenbach. And Nicole Fehrenbach is the chief of the Rapid Response Research and Surveillance Branch at the National Center of Emerging and Zoonotic Infectious Diseases. Division of Infectious Disease Readiness and Innovation is where she leads rapid responses to infectious disease outbreaks. She's held leadership roles at the Centers for Disease Control and Prevention during public health emergencies, including H1N1, Zika, COVID-19, Operation Allies Welcome, Mpox, Ebola, and Marburg. Ms. Fehrenbach holds a master's degree in public health policy from Georgetown University and a bachelor's degree from Rosemont College. And she completed her doctoral work in public policy, focusing on health policy and information technology at the Georgia Institute of Technology and Georgia State University. So thank you very much and welcome.
Well, congratulations, everyone. You've made it through 2 absolutely amazing days. I have to say the presentations, the sidebar conversations, the posters have just been phenomenal. And I would like to take a moment to deeply, deeply thank our WEF colleagues and the planning committee. You all put together an extraordinary summit. So thank you. So not terribly surprising, given the theme of what we're talking about. I think we can safely come to an initial conclusion at the close of this summit that wastewater surveillance is valuable, it's efficient, and it's robust. It helps us improve our situational awareness and guide public health decision-making across the nation. And there are lots of questions. We've gotten to the point of we are able to see spaces where we can see the direct connection between our wastewater surveillance work and public health action being taken, seeing connection between our work and preceding that of clinical identification, giving communities early warning and helping us better understand what may be occurring, what risks might be accruing in our community, so that ultimately we can do our job of preventing the spread of infectious diseases and other health threats. So we've done a lot. And as we've seen through the past 2 days at this summit, we've done a lot of work while maintaining the core of who we are when we think about why we do public health. So we're using our data, we're figuring out how to be transparent with it. How does it become something that is interpretable by the different sets of the public and our public health audiences that we serve? And how do we want to use it in different situations as our technology enables us to identify different risks and different pathogens, different concerns that are in our wastewater, and how that can be applied within our day-to-day work and at a community level, state level, and federal level. So within this past 2 days, we've seen we've had some wonderful conversations about sub-sewer shed sampling, whether from schools or airplanes, and what are the risks associated with that. And we had some interesting conversation, and you all tagged certificates of confidentiality as being a wow, a new insight that you gained, and how can those be utilized. Heard lots of chatter on the interesting conversation about the dual benefits that can accrue to utilities and public health, with the example provided from the dye runoff from a clothing factory. And so where else can we find those benefits? What else becomes possible where the benefits accrue not just to public health, but the various other actors and entities we engage with? And how can we help do our job on the public health side, recognizing the connection that we have to amplify and extend those benefits? We're detecting different pathogens. The poster presentations have been marvelous, and they identified specific areas where wastewater is able to determine what is wild type versus vaccine preventable conditions, other areas where the virus can break down in unique ways, and how do we think about being able to detect it from a variety of different laboratory methods that we have. Lots of discussion about the emerging and growing field of pathogen genomics. How do we leverage that in the wastewater situations? Where is it cost effective? Where does it provide value? And where might we want to pause and think? And then finally, the engagement with partners. We've talked a lot about our jurisdictional and our utility partners. I want to recognize again our non-governmental membership partners, our ASTO, NACHO, CSTE, APHL, National League of Cities, Big Cities Health Coalition. All those groups help to advance our work. In addition, there are the non-governmental partners that represent our shared workforce, such as WEF, ASM, and others, that help us get our message across and maintain our connections, not only to the public, but to others that are decision makers that affect and amplify or concern or constrain the work that we do. So where do we go from here? And so one of the pieces I want to talk about are a couple of things happening for the federal level and how to build on the work that you all have presented these past 2 days so that when we get together again next year, we will have even more innovation and we'll keep that innovative curve so steep, continuing to climb. So right now, we're in the middle of our H5N1 response. And we're looking at how does wastewater data inform what is happening in communities? What does that risk mean when we are detecting that on-off signal? And then how does that compare with the influenza A data that we're being received from all of you and that we are able to visualize? Right now, we are visualizing information in a specific structure, looking at data that was reported from October through March as a baseline, and then what is happening now in terms of where are we seeing our influenza A measures raise something of concern. Recognizing that this is not necessarily the way we want to go long term. How can we begin to transform and shift to a WVAL method? And then also continue to look at what is happening from the H5 perspective and compare it with the other clinical systems, other established public health tools that we have to try to make sense of the signals we are seeing and what potential risk it may or may not pose to humans outside of the effect that it's having on livestock and wild birds. Also looking to how do we expand to other infectious diseases that can be risks to certain parts of our country and our shared nation, such as diseases spread by mosquitoes. So right now we're engaged in work collaboratively with APHL and our partner Verily with looking at dengue and having wonderful conversations with several of the colleagues who are here in the room as they are starting to look at West Nile virus in particular. As these threats shift and as mosquitoes may travel to different spaces, how do we understand the risk that that poses for different communities? And how can we get that information to help support vector control efforts and inform clinicians who may be thinking about what is walking through their doors? A couple of other areas to highlight is, as you've heard smatterings throughout this conversation these past 2 days, CDC continues to invest in our jurisdictional support so that we can have these types of advancements happening, being able to hear from many of the leaders in the field. And so we've been able to expand our communities of excellence, our centers of excellence, excuse me, from 4 to 6. And so now we are inviting New York and North Carolina to join that group with the established group that we've had the partnership with California, Colorado, Houston, and Wisconsin. In the ethics front, we are working collaboratively with ASTO and several of other leaders in the field to develop an ethics framework, engaging our board of scientific counselors. We will be engaging our centers of excellence, and then we want to hear input from all of you. There are structured groups across the agency that we are partnered with to get that input. Also recognizing for all the conversation that we've had the past 2 days that guardrails are necessary, particularly at the national level. And there's been incredible work done at the community and local level to be thinking about what guardrails need to exist. And different decisions have been made thus far. We've heard very contrasting conversations in the past few days about the types of pathogens or other health risks or perceived health risks, depending where one sits, and whether or not wastewater would be useful in that particular space or not. And then thinking about pathogen prioritization, Jonathan shared a very useful slide that connects also with several of the conversations that we've heard in the past 2 days about how do we select these pathogens. And for those of you who have been actively engaged in the wastewater surveillance space for the past several years, you've seen different lists come out from us. And so CDC has put out concepts and proposed lists of pathogens, and we are walking back from that now, in part because of the really good work that the field has been doing, where the field has seen pathogens of importance that need to be prioritized that also have technical feasibility and a relationship with public health action. And so instead of providing lists now, thinking about a framework that enables us at the federal level to have these conversations about what pathogens can be prioritized, how do they link in a way to public health action, and now adding community acceptability, community support. So bringing in that ethical framework, bringing in that connection to the privacy concerns, to the community level concerns, how does that relate to the pathogens that we think are critical and important, because will that actually be used? And then finally, the question that's on all of our minds, sustainability. How does this go forward? As you are all aware, we have been funded by COVID dollars for many years, and we have been blessed with being able to invest about $500 million over that time into supporting the development of this field through the grants to the jurisdictions, through contracts, through different innovation grants that have been provided to our academic partners to bring forth this field in a way that usually does not happen. So for those who've been in public health for quite some time, we don't usually see a new surveillance strategy built, expanded, and institutionalized at a nationwide level in about 4 years. And that is a commendable and extraordinary accomplishment. So how do we sustain that? How do we leverage this workforce that we've built, expand upon these laboratory methods and breakthroughs that have occurred, and keep the data being connected for public health action? So there are two pieces I want to highlight in this space. One is the FY25 President's Budget, which also was connected in the Senate markup. So for those of you who are policy wonks, that's important to see it in the Senate markup. And this is for $20 million for FY25. And so this would be able to provide sustained, dedicated funding, and it's an initial step for wastewater surveillance. So for us to actually have that line in the budget that says, we believe wastewater should be funded year over year. So for those who work in a variety of other programmatic areas, those other programmatic areas typically have dedicated funding. So there is an immunization line, there are different influenza lines, et cetera. So this is the first critical step. In addition to that, I want to also acknowledge the incredible work by our WEF and ASM partners. There is the Sewer Act that has been put forward. It crosses both political sides, and that is proposed at this point. It doesn't have a number assigned yet, but it is proposed, and also a very critical step for $150 million a year. So if we think of the $500 million that's invested thus far, the 150 is obviously one that resonates, but we are also incredibly grateful for the 20 million, because that gives us this first foothold in how we can move our programs forward into being something sustainable. So I look forward to seeing our field continue to evolve. The work that you are doing informs, creates questions, acknowledges challenges, helps us understand what the horizon is, where it can be possible in different spaces, and enables us to make advancement. So I look forward to next year for another amazing WEF Summit. This was an extraordinary 2 days. And again, thank you for all your work. Thank you to WEF, and thank you to the Planning Committee.
Thank you very much, Nicole, for those wonderful closing words. I think, yeah, wastewater surveillance has a bright future ahead. So, I mean, look at all the bright minds we have in this room, just passionate and engaged. So if we keep this up, I don't see how it could fail. So keep up this great work and come back again next year, and hopefully for future workshops as well. And with that being said, yeah, give us your feedback, especially on today's and yesterday's summit. And there'll be questions on there too that are really important for us. Like, do you want to go to a workshop or just the summit or both? So we know where we should spend our resources. And plus it'll help us improve. So please give us feedback. Do it now. And join us at WEFTech if you're interested. We'd love to see you there. And one final thing is submit a case study. So if your community has a really interesting case study on wastewater data usage, we've got, well, we're trying to build a repository of these. So you can scan that final QR code at any point, or go to our nwbe.org website to submit those case studies. And I want to thank our CDC partners, because with them, we're able to bring you all here together, and the support has been amazing. But mostly thank you all who are here today to allow this to be possible. We really appreciate the support and the engagement. So with that, have a wonderful day, safe travels back to wherever it is that you guys all are coming from, and we hope to see you again very soon. Thank you.